Find the derivative of the function y equals x squared times the square root of 16 minus x squared. So before we get into the problem, let's talk about the derivative rules we've covered so far. And I said there's 4 main general derivative rules that we're going to be applying over and over and over as we study calculus. And those 4 rules, well, we talked about the power rule first. We talked about the product rule. We talked about the quotient rule. And we've talked about the very powerful chain rule. So it looks like in this problem, 3 of these 4 rules apply. We have exponents, so we're going to use the power rule. And we have a product. We have x squared times the square root of 16 minus x squared. So we have to use the product rule. And since the square root, we have the square root function applied to the 16 minus x squared, so that's a situation where we also have to use the chain rule. Okay, so let's rewrite this function. So it's y equals, right, so we have x squared times 16 minus x squared to the power of 1/2. Okay, so the product rule is where we start, because that's the rule that applies to the entire function, the whole x squared times 16 minus x squared to the 1/2. All right, so we start with the product rule. And inside the product rule, we have a chain rule situation. So when we take the derivative of the second factor in the product rule, we need the chain rule for that. So let me write it out sort of in full detail. So we'll say y prime should be equal to the derivative of the first function, and we leave the second function alone, 16 minus x squared to the 1/2, and then switch it. Leave the first function alone and multiply that by the derivative of the second function, which is 16 minus x squared to the 1/2 power. So it looks like here we're going to have to apply the chain rule. Okay, so let's see what we got. Y prime is equal to derivative of x squared is 2x. Okay, so we have 2x times 16 minus x squared to the 1/2 power plus x squared, and then we'll use the chain rule here for the derivative of the 16 minus x squared to the 1/2. So the 1/2 power comes out front and decreases by 1. So 1/2 minus 1 is negative 1/2. So it's the derivative of the outside function, which is the 1/2 power. Inside function stays the same, times the derivative of the inside function. So the derivative of 16 minus x squared. So the derivative of 16 is 0. And by the power rule, the derivative of negative x squared is a negative 2x. All right, so off the bat, it looks like this 2 will cancel this 2. And let's see what we have. Y prime is equal to 2x times 16 minus x squared. Oh, not negative, that's positive 1/2. Okay. Plus, we have an x squared here, and we have a negative x here. So that's a negative x to the 3rd power, so that actually becomes a minus sign. X to the 3rd power, and this negative exponent we can move to the bottom. 16 minus x squared to the positive 1/2. All right, so now we can combine these two terms by getting a common denominator. So let's go ahead and put this over 1. And we can multiply 16 minus x squared to the half to the top and the bottom. 16 minus x squared to the half. Okay, so it looks like we have a 16 minus x squared to the half times a 16 minus x squared to the half. So we add those exponents. That's 16 minus x squared to the first power. All right, so this is looking like it's simplifying nicely. So we have 2x times 16 minus x squared. And then in the second term, we have a minus x to the third power. And this is all over 16 minus x squared to the half. Okay, so let's combine some like terms here. So let's multiply. Let's multiply through that the 2x. So we'll have 2x times 16, so 32x, minus 2x cubed, 2x times the minus x squared, and then there's a minus x cubed. So we could definitely combine those. Okay, so it looks like we're at 32x minus 3x to the third power divided by 16 minus x squared to the 1/2. All right, I think that's as simple as we could get this one. So here is the derivative. Final answer.